Welcome. While we have already dealt with wood systems in some of our prior modules, during today's session we will be discussing wood, the material. Wood is a natural material and by its very nature may contain different characteristics and defects that need to be understood and allowed for in any given application. Lightweight, strong, and durable, wood is an ideal construction material with many uses. Look at this in the next slides and we'll discover some of wood's uses together. We use wood as roofing and siding, as framing, we've already talked about that, as blocking, we've already talked about that, paneling, we're going to be talking about that, trim, we've talked about that, whether interior trim or exterior trim. Still use the phrase trim for the molding, cornices, and other types of accessory uses, decorative uses. Cabinetry, we're going to be talking about those as well. We have flooring, another topic. We have doors, we've spoken about doors. Windows, we're going to talk about glass, not so much windows. We've talked about the light in windows, and we're going to be talking a little more about the glass in the window. We are not dealing in furniture, but you of course know that furniture is often comprised of wood. We're not talking about paper or packaging. We like wood because it's natural. Wood is a renewable resource. We will talk about wise forest management. It assures a permanent supply over time to meet foreseeable future needs. We've already spoken about sustainability. Wood is prized for its decorative character, which is derived from a tree's variety of grain, texture, hue, and other natural markings, which are important in wood products such as flooring, windows, doors, millwork, and the like. The wide range of properties in wood makes it suitable for use in many structural, non-structural, and decorative products, and hundreds of end uses. It has high strength relative to its weight in compression, tension, bending, and resistance to impact. Wood can be easily worked to desired shapes with simple tools. Wood has high durability when simple precautions are observed and has excellent insulating qualities. Foresters can grow trees faster than nature can without their assistance. As a result of reforestation and other conservation practices, the yearly growth of timber nationwide exceeds that harvested or lost to fire or disease. Because of this ready availability of native species, the cost of domestic lumber can be relatively inexpensive, though the situation changes for imported lumber. With proper preparation during and after milling, a piece of wood can retain its dimensions in service. There are some woods, such as cedar, which are aromatic. Perhaps you've heard of cedar closets. Finish is used on woodwork to protect it from moisture, chemicals, and contact, and to enhance its appearance. Woodwork can either be field finished or factory finished. Because more control can be achieved with a factory finish, it is the preferred method, though minor cabinet and trim work is often field finished. All woods are flammable, but the rate of burning depends on moisture and resin content. Wood species are graded by the flame spread index, a measure of the distance spread on a flat wood surface under standard conditions, and the room corner test, which simulates full-scale conditions of a house fire. Flame retarding treatments reduce the rate of wood burning by a factor of up to 2, but do not prevent it. Because of these complexities, wood and wood-derived products are all rated as highly flammable. Warp is the deviation from flatness as a result of stresses on and within the material itself. These stresses are most commonly caused by shrinkage and expansion by one or more of the surfaces of the material, causing it to distort. The image on this slide shows some common types of warpage. The exact result of the stress is not predictable and depends on the material itself and often the climate. Splits and cracks are ruptures or separations in the grain of the wood which reduce the quality as measured by appearance, strength, and usefulness. The dimensional changes that accompany the shrinking and swelling of wood are major sources of both visual and structural problems. Shrinking and swelling occur as the wood changes moisture content in response to daily as well as seasonal changes in the relative humidity of the atmosphere, such as when air is humid, wood absorbs moisture and swells. When the air is dry, wood loses moisture and shrinks. If a hardwood plank is not cut properly, it can splinter at the edges. Over time, the finish on a hardwood floor can deteriorate. Without a protective finish, the wood becomes hypersensitive to moisture and temperature changes, which leads to splintering. The boards may also loosen and shift slightly each time you walk across them, causing them to rub against each other. Eventually, this will cause the edges to fray and split. Dry rot is a process that eats away at the wood and leaves it brown, decayed, and deformed. The damage begins when excess moisture enters the product and forms a fungus that feeds on the cellular structure of the material. Left to its own devices, dry rot can destroy an entire wall in less than a year. Mold is easily identified. It can be any one of a variety of colors, but white, green, and black are the most common shades to find on wood. It almost always gains a foothold from excess moisture, and once present, must be eliminated to prevent an unhealthy atmosphere. It can usually be destroyed using a good solution of bleach and water. But even after it is treated, it is common for a stain to be left that will not disappear. Termites are a real threat to every homeowner. When these little insects are present, you will find hard mud trails running the length of the wood. Here are these little trails. To determine if the trails are new or old, break through the surface. If there are small winged insects inside with straight antennae, it is time to get out the termite treatment. If there are larger insects inside with double antennae and are a darker color, these are winged ants and must also be dealt with. Big box stores tend to buy lumber as a commodity in standard sizes, wrapped in plastic with limited selection. But with that said, most softwares are processed into standard sizes. However, hardwood sold through lumber yards that service small shops, small cabinet shops, trim makers, they will have a random width stock and a variety of thicknesses as well. One place to get lumber in unusual widths and thicknesses are small local mills. The cost of the material is dependent upon supply and demand, seasonal fluctuation, and point of origin. Again, the availability of the material is dependent upon supply and demand, seasonal fluctuation, and point of origin. The mold and mildew spores are just about everywhere. They are on the wood surfaces and can be transported there by wind and rain. Once in place, all they need is water to start growing and flourishing. Some lumber provides plenty of food for the mold and mildew to grow rapidly. When you see the black mold cover wide areas of lumber, usually this happens because the wood got wet and stayed wet while it was being stored. If it's warm and humid, the growth of the mold and mildew can be rapid. You can test for structural integrity yourself. First, make sure the lumber is dry. Take a nail with a sharp tip or a key and see if you can push it into the wood with just your hand. If you meet immediate resistance, the wood is probably fine. If the nail or key head using hand pressure penetrates deeper than 1/4 inch, then you could have wood rot. When wood is no longer usable, it can be readily absorbed back into the earth with no environmental harm. Wood fibers turn into non-toxic dirt and enrich the soil as they decompose. On a building site, wood scrap can be chipped and composted immediately with no hauling and no land filling required. Wood grows naturally and is renewable. Responsible forest management helps to ensure that forests are legally harvested and managed to meet society's long-term demand for forest products. In the context of forestry, sustainable development can mean the harvesting of trees and other forest products at a rate that does not exceed the capacity of the forest to regenerate itself. Wood from old-growth forests are certainly a renewable resource, but extracting resources from them is generally frowned upon by environmental groups in favor of protecting the biodiversity of these natural assets. Rather, it is generally agreed wood should come from plantation forests, and even better, from rapidly renewable species, considered a species with a growth and harvest cycle of 10-year or less. Bamboo is one such species. Bamboo has a harvest cycle of 5 to 7 years, making it rapidly renewable. Trees act as natural filters as they remove pollutants from the atmosphere and thus improve air quality. Each tree is a small air-purifying, dust-absorbing factory, and at the same time a small oxygen-making factory. Deforestation is clearing Earth's forests on a massive scale, often resulting in damage to the quality of the land. Forests still cover about 30% of the world's land area, but swaths of the size of Panama are lost each and every year. Recycling timber has become popular due to its image as an environmentally friendly endeavor. Timber recycling, or wood recycling, is the process of turning waste timber into usable products. Certain products that emit VOCs, volatile organic compounds, are considered volatile because they evaporate or vaporize readily and are harmful to human health and the environment. And they're considered organic because they're carbon-based. Some aspects of the forest products industry may emit VOCs. The Forest Stewardship Council mission is to promote environmentally sound, socially beneficial, and economically prosperous management of the world's forests. FSC was founded in 1993 to promote responsible forest management. FSC is an independent, nonprofit organization that protects forests for future generations. This organization sets standards under which forests and companies are certified. Chain of custody is the path taken by raw materials from the forest as they find their way to the consumer. The COC, chain of custody, includes each stage of processing, transformation, manufacturing, and distribution, where progress to the next stage of the supply chain involves a change of product ownership. Conformity with this standard provides a consistent international basis for independent third-party verification of claims regarding the sourcing of forest-based material and products. For a product to be claimed as FSC certified through a product label and/or sales documentation, there must be an unbroken chain of certified organizations covering every change in legal ownership of the product from the certified forest up to the point where the product is finished and sold to the end consumer. This assures the specifier of wood that their material comes from a sustainably responsible provider. I'm going to talk a little about the anatomy of a tree, just because of the impact it has on the tree's appearance when we use it as a material in our construction. Photosynthesis is arguably the most important biological process on Earth. By liberating oxygen and consuming carbon dioxide, it has transformed the world into the hospitable environment we know today. Directly or indirectly, photosynthesis fills all of our food requirements and many of our needs for fiber and building materials. There are few organisms as important as trees for gathering sunlight and providing Earth's ecology. The biosphere is dependent on the metabolism, death, and recycling of plants, especially trees. With their vast trunks and root systems, trees store carbon dioxide, move water, and produce oxygen that is released into our atmosphere. By liberating oxygen and consuming carbon dioxide, trees change the world. The organic matter of the soil develops primarily from decayed trees, twigs, branches, roots, and fallen trees, all of which recycle nitrogen, carbon, oxygen, and other important nutrients. The pith is the soft, spongy central cylinder of tissue in a tree. Annual rings, such as you can see in this slide, also referred to as tree rings or growth rings, can be seen in a horizontal cross-section cut through the trunk of a tree. Growth rings are the result of new growth. Visible rings result from the change in growth speed through the seasons of the year. Thus, one ring generally marks the passage of 1 year in the life of a tree. Heartwood is the mature, darker color central supporting pillar of the tree. Although dead, it will not decay or lose strength while the outer layers are intact. It is in many ways as strong as steel, and therefore is very desirable. Sapwood is the lighter colored wood growing from inside the bark to the heartwood. Sapwood is the tree's pipeline for water moving up to the leaves. Sapwood is new wood. As newer rings of sapwood are laid down, inner cells lose their vitality and turn to heartwood. Medullary rays are an important part of a tree's biology, supplying water and nutrients as the tree grows. These large bands of radial cells emanate outward from the center of the tree, similar to the spokes of a wheel. The cambium cell layer is the growing part of the trunk. It annually produces new bark and new wood. The inner bark is the pipeline through which food is passed to the rest of the tree. It lives for only a short time, then dies and turns to become part of the protective outer bark. The outer bark is the tree's protection from the outside world. Continually renewed from within, it helps keep out moisture in the rain and prevents the tree from losing moisture when the air is dry. It insulates against cold and heat and wards off insect enemies. Think of the cells as drinking straws, packed together. No matter how tightly they are connected, there is still room for water to move up and out of each straw. Springwood is the part of an annual ring of wood characterized by large, thin-walled cells formed during the first part of the growing season. Summerwood is the wood that is produced by a tree near the end of the growing season. It consists of small, thick-walled cells. As we have in previous sessions, it is time to learn some new vocabulary and concepts specific to wood. In this slide, we can see that a log can be cut into many different size pieces of timber. The inside is usually the large, hard wood cut into posts and large timber pieces, while the outside is generally for boards. In between is where we get the lumber for 2-bys and other types of framing material. But it's up to the miller to determine the best way to cut a particular trunk of a tree to maximize its productivity. We've talked about the actual and nominal dimensions of lumber due to the shrinking process from when it is first harvested. When it's first harvested, we're calling that wood the green lumber, and it has maybe 80% water content. In the process of being sold to the consumer, that lumber has to be dried. So we call that seasoning to lumber, so that it can be dried to within 10% water content. This log contains that much water, so there's a lot of water to be drawn out of the wood so that it can be shipped to a job where it won't move or shrink or expand once it's been installed. This is a meter. They are measuring the water concentration in that piece of wood. The two processes for seasoning lumber are air dry, where the wood is stacked but with gaps left between each individual piece, and the air simply circulates under a sheltered area, and it will eventually dry to the specifications of the mill. Or it can be speeded up and dried in a kiln, similar to a type of kiln you might use to dry pottery in advance of putting a glazing on it. So it's a similar situation, but it's an accelerated process. We talked about that a 2x4 shrinks to 1.5 by 3.5. Some terminology that we have spoken about already is that the green lumber, when it's harvested, is also known by its nominal dimension, before it's had an opportunity to dry and shrink. And we detail, as we've said, around the actual dimension, not the nominal, but the actual, as the material is going to appear on our job. So a 2x4, we're going to detail that as a 1.5 by 3.5 because that's the size of the material that the contractor is going to actually be working with on the job. Notice in this slide that over 8-inch nominal, the shrinkage increases to 3/4 of an inch from 1/2 inch. So 6 to 5.5, 8 to 7.25, 10 to 9.25. So the shrinkage increases to 3/4 of an inch once you get past a 2x8. Deciduous trees have leaves. So when we look out into our forest in New England, our trees are mostly leaf-bearing. Those are called deciduous trees. When we look out and we see a forest of pine trees, those are coniferous trees, trees that have needles, like our Christmas trees. Coniferous trees have cones and needles. Palm trees and bamboo, we call them trees, but technically they're classified as grasses. They're readily renewable, so when we talk about readily renewable forestry, we're generally thinking of trees that will be ready to be harvested in 10 or fewer years. Deciduous or coniferous trees, they could take a generation, maybe 20 or 25 years, before they're ready to be harvested. So renewal of those forests also take a longer time. Let's go through the next slides and look at some different types of woods. For your information, I'm not going to hold you responsible. I will point out a couple of things that perhaps I'd like you to remember for the future or for an exam, but generally for informational purposes only. So here we have red oak and white oak, white oak and white oak. Hopefully you can see the subtle difference in the hue of the wood. But above that, I want you to also notice the appearance of the grain is different in each of these samples, and that's a consequence of the way each of those trees was sawn. And we're going to talk about that more in a second. This is domestic hardwood that we're going to look at now. Hardwood is generally considered wood from a deciduous tree, a tree with leaves. So it's the type of wood that we would normally see as a finished product on a podium or a piece of furniture. Something that our eye is going to see is generally hardwood. What we're not going to see, maybe the substructure or the framing of the house, is going to be a softwood that comes from the coniferous trees, the trees with pine needles and cones. So this is, again, white oak, a floor and panel. This is red oak, floor and ceiling. English brown oak, darker still. Maple. Maple is a material I'd like you to remember for yourselves, but also for the exam. What we like about maple is that it's resilient, but does not splinter. Our interior athletic fields and courts are made generally out of maple because they are resilient, soft on the foot, but with use they're not going to splinter. So we see maple on the floors of racquetball, basketball, squash courts. We also have beautiful cabinetry with maple finish surfacing. Cherry is another beautiful finished material. It's available light cherry or dark cherry appearance. We have ash. Ash is a material used by designers who favor minimalism. It's very clean, straight lines, light colors. Pecan hickory. I love this photograph where there's three materials all equally pronounced but so different in texture. We have the rough concrete floor, smooth concrete columns, and beautiful soft wood texture. Pickled cypress, if you like that type of rough hewn appearance. We have beech, poplar, and birch. I'd like you to remember these three. These are also hardwoods, but these are hardwoods that we use primarily to be painted. They're good woods, but their physical appearance is not something generally that is as nice as some of the other woods. So we use these three types of woods as veneers on closet doors or doors that are going to be painted. We use them on surfaces for paneling that are going to be painted. Things that are not going to be left exposed. Type of wood being used after the American Revolution, when mahogany, which was the favorite wood of craftsmakers at the time, was no longer available from being imported from our former enemy Great Britain. Cabinetry makers had to turn to something that was more readily available domestically, but it didn't look very nice, so we saw a transformation from mahogany finished furniture to painted finished furniture. So here's a wall paneling and a door that were painted instead of beautiful mahogany appearance. Teak is another beautiful wood. It ages very nice. It makes a nice silver. It lasts a long time if you use it outside. And the nice thing about teak is that you can refinish it, sand it down, and it will then look new again. So it's a beautiful gray when it ages, but if you don't like that color, by properly maintaining it or sanding it, you can keep it retaining its original luster. Sapele, another type of wood, but this is an imported wood, tropical hardwood. This material is often used in violins. Perhaps you can recognize that. Another tropical hardwood, these are imported woods, so they're much more expensive, somewhat more limited in availability. Rosewood, of course, perhaps you recognize that chair when it originally came out. It was real rosewood. Nowadays it's a simulated material to look like rosewood. Rosewood is endangered and very, very expensive. Here's some more tropical imported hardwoods. Ebony, you probably know from the Black Keys on the piano. Purple Heart, if you've ever been in the Woolman Rink in Central Park, the pergola in front of the skating building is made out of Purple Heart. It's more than 45 years old already and very little damage. Domestic softwoods, these are woods harvested in the United States, meaning that they are coming from the cone trees with needles, coniferous trees, and they're used as the framing material or the structural submaterial below what we see as the finish. So any of these would be a framing material for a house. Douglas fir is probably the strongest, so that would be your first preference, but hemlock and pine are also available. Pine, cedar, all of these are domestic softwoods. We often see pine floors, pine cabinetry. You can usually distinguish pine because it has, if not a lot of knots, at least has some knots visible. That's the characteristic people like from pine. It is a very soft wood. If you're going to use it on a floor, you have to warn your client that if they drop something, chances are there's going to be a permanent dent in the floor there. Dropping pots or pans on the floor are going to easily damage that floor. Redwood comes from another type of coniferous tree. When I was growing up, our picnic tables and benches were always made out of redwood because they worked well in the exterior, although they do lose their color and cannot regenerate the color the way you might with a piece of teak by sanding it. I mentioned some wood types that are technically grasses, such as palm and bamboo. Very interesting that these are now very popular and available on the mass market through places like the big box home improvement centers. We are used to standard sizes like 1x6s, 1x12s, 2x8s, but in this slide you'll notice some fractional widths as well. In short, these fractions refer to the thickness of the hardwood lumber. The thickness is expressed as a fraction and goes in increments of quarters of an inch. So a 4/4 is equal to 1 inch. A 5/4 is equal to 1 1/4 inch. A 6/4 is equal to 1 1/2 inches, and so on. You're going to go into a local lumber yard and you're overhearing a contractor or carpenter specifying, yeah, I want 5/4 in 10-foot length. He's talking about a board 1 1/4 inches wide by 10 feet long. So that's how tradespeople designate their fractions for boards. I'd like you to take a look at the next two slides and try to learn about the grading of the lumber. So we see that boards are materials that are 1 1/4 or 5/4 inch or less in the least dimension, and it's generally used for siding, trim, and subflooring. So here are some boards. So when we get up into a little heftier lumber, such as 1 1/2 to 3 1/2 inch in the least dimension, these are what we call the framing material for our structures, general construction framing, and blocking. So we have boards for shelving, for instance, dimensional lumber for framing. Then we have timbers over 3 1/2 inch in the least dimension, used for large framing members, heavy structures, and posts. While lumber of the same species and size is at the mill, it is designated and separated by grade. It is then identified by a stamp and often inventoried by its grade and species. So here is a stamp designating the grade and species of this piece of pine, WP. It's number 1 common. Grade designations depend on particular defects such as knots. Keep your project final results in mind when selecting the grade of wood. Grade does not indicate consistency of color or grain pattern. Grading designation depends on the number of defects in a board. A lower grade can be perfectly acceptable, depending on placement and usage. Hardwood lumber is usually graded on the basis of the size and number of cuttings, pieces, that can be obtained from a board when it is cut up and used in the manufacture of a hardwood product. The upper grades provide the user with long, clear pieces, while the common grades are designed to be resawn into shorter, clear pieces. Material we call select is almost completely clear of defects, widely used for interior trim and cabinets. Visually compare the various grades in this photo on the right. Note how they get uglier and uglier. Clear, select, to number 3, uglier and uglier. Number 3 can still be a good piece of wood, it's just not as pretty as number 1. So C1, common, best material for high quality pine with a knotty look. Knots will be tight, meaning they won't fall out and are generally small. 2, common, tight knots but larger than found in 1, common, often used for paneling and shelving, very suitable for general woodworking projects. And 3, common, knots larger than in 2, common, also used for paneling and shelving, but especially well suited for fences, boxes, and crates. Engineered wood is a composite wood made from pieces of recycled, reconstituted scrap wood and fibers bonded together with adhesives to create a durable and resource-friendly substitute for solid, raw sawn lumber. Engineered wood are woods made from alternating veneer inner plies. In North America, the inner ply species are usually a softwood, such as fir or pine. Veneer core panels are relatively light in comparison with other engineered composite panels, typically weighing about 70 pounds per 3/4 inch 4x8 panel. Veneer core offers great strength and stability with good spanning properties. By veneer core, we mean the sandwiched veneer layers which are not the face layers. The number of core veneer layers determines the thickness of the panel. Hope you can clearly see in this slide the stacking of the veneers, and here you can see veneers in the raw form before they are adhered one to the next. As an element in design, face veneer, that means the panels on the outside, which are going to be visible over the inner layers, provides the utilitarian panel with natural beauty and visual dynamics. Veneer is used as a method for creating individual design statements in design projects of all categories. Selection of this wood surfacing can provide our clients with a natural, comfortable ambiance in their design spaces. Veneer is a naturally grown raw material, with each type of wood having its own unique characteristics, coloring, markings, structure, and appearance. We're going to take the next few slides together so you can see some of the options. To create a veneer, we have either rotary peel cut, slice cut, or sawn cut. The rotary cut is the cut that is used to create the inner layers of those engineered plywood boards. The outer layers can be decorative and be composed of any type of slice or combination that you would want. As we're going to see, the type of slice determines the appearance of that outer layer wood. So here we can see the rotary cut. The log is rotated and slivers of shavings come off of it and create the thin veneers. This is the pattern that you would get, not particularly attractive, from a rotary cut. Here's a little better. Here's the chisel edge of the knife, and as the log rotates, a thin veneer is cut. Another type of slicing is the flat cut. Here's a picture of what that incorporates, and it leaves us with what's called a cathedral or butterfly grain pattern. A quarter cut veneer, pretty much perpendicular to the center, gives us this kind of quarter cut veneer. It's kind of straight grained. And a rift cut is a perpendicular to the center with a slight curve to it. Creates what was called a flake or splotchy design. Once you have your veneer cuts, you can place them in a pattern. Perhaps it's a repeating pattern of your choice. to create the effect that you want. Such as you can see here, book matching, slip matching, plank matching, and random matching. We've described engineered wood as being a composite wood product made from pieces of recycled, reconstituted scrap wood and fibers bonded together and alternating veneer interplies with adhesive to create a durable and resource-friendly substitute for solid, raw sawn lumber. The term engineered wood can apply to wood flooring, wood framing members, and wood structural members which are manufactured in the manner described. Veneer core plywood has a finished wood grain surface veneer and is relatively lightweight and easy to handle. As we said, the face veneer is available in many species to suit your individual decorative need. Plywood is produced by superimposing and gluing together several layers of wood with their fibers crossed perpendicularly. This procedure, called cross-lamination, confers good rigidity, mechanical strength, and dimensional stability on the product. Plywood can be made from either softwoods or hardwoods. The layers in plywood are aligned according to a predetermined arrangement, so as to obtain equivalence of its properties of stiffness and strength in the main directions of the board. Here you can see the alternating of the individual veneers in directions that will benefit the final board. In cross-lamination and gluing of plywood, capitalize on the wood's most desirable physical and mechanical properties. Compare here the capacity of the different materials in this slide to support the identical loading of books. I'm pointing specifically out that a 3/4 inch piece of plywood will sufficiently span a 36-inch space unsupported when loaded with books. We've spoken before about methods of attachment. There is a screw style appropriate for use with just about any material, and that is the correct screw for the designer to specify. Particle board core plywood is produced by heat pressing coarse wood chips and shavings and a binder or glue into panels. As the surface is generally rougher and less consistent than plywood, it is an ideal substrate for many products, such as stock cabinetry and furniture. Medium density or high density fiberboard, MDF or HDF, is produced by applying heat and pressing a mixture of fine wood dust and a binder or glue into panels. Paint grade blank sheets can be used as they are or with a veneer skin. Though ideal for uses in cabinetry and shelving, these boards are also very heavy. Edge banding is the application of a solid surface finish to cover the exposed sides of materials such as we just discussed, increasing durability and giving the appearance of a solid or more valuable material. Here you can see the exposed edge of a piece of plywood, and we want to cover that with an edge band to make it look like a solid board. We can also use that edge band in different appearances or thicknesses or contrasting colors to create a design statement. Edge banding can be wood, you can see in this slide. It can be plastic, as you can also see. It can be in the form of T-mold, or it could be a self-edging where strips of high-pressure laminate can be applied to the edge using an adhesive or ironing on. Excavators in some countries have pulled workable logs from soggy ground that have been preserved for up to 50,000 years. Bogwood is wood extracted from trunks of trees that have been buried in peat bogs and preserved from decay by the acidity and anaerobic bog conditions. In the waters of our own Great Lakes are logs of red oak, yellow birch, white pine, and maple that were lost between the mid-1800s and the early 1900s, while the wood was en route to lumber mills. The late 1800s and early 1900 logs that were tied into rafts and floated to the lumber mills for processing was a common sight during those days. Although the plan was always to get all the logs to their ultimate destination, sometimes these hand-cut timbers sank to the bottom of the rivers while in transit, or while they were waiting for processing in holding ponds. The Department of Environmental Protection's Office of Submerged Lands and Environmental Resources estimates that about 10% of these logs were lost before they were able to reach the mills. These sunken logs came to be known as sinkers or deadheads. Underwater for up to a century, the bark and sapwood of the log decomposes, but the inside is perfectly preserved. This interior wood is the heartwood, valued for its beauty and durability. Using river reclaimed wood helps preserve our forests by utilizing timber harvested hundreds of years ago while also providing a high-quality lumber. Due to its extreme durability and resistance to rot and pests, such lumber has found a wide variety of new uses, from exterior building applications to interior paneling, tongue-and-groove flooring, trim, ceilings, moldings, tabletops, and beams. Thank you for your attention. See you again soon.